Good morning. Happy Thursday. Congratulations on finishing your last Illuminate yesterday. Today, we're going to start some new math. We're going to start focusing on what we're going to start calling linear systems. So today will be our introduction to linear systems. At this point, you already should have read through today's objectives and key terms. And you also should have already attempted to complete today's exploratory problems by working with your partner, using resources like Google, reading through the objectives and key terms again, anything you can do to try to figure out some of this new math on your own. At this point now, you're on step 3. You're going to go ahead and analyze your work on the exploratory problems by watching today's video recap. I'm going to first take a look at our objectives today and our key terms. Since this is new math, we really want to take some time to read, understand some of these new ideas. We're building on the idea of a linear equation. Something we already knew. Those were equations between two variables, usually x and y, and they gave us straight lines when they were graphed. That's why we called them linear equations back in the fall. The big thing we're going to add today is what's called a linear system. And we just need to understand that a linear system is a group of two or more linear equations, and we deal with these together at the same time. As we get into later next week, we'll talk about why in the real world a lot of times a linear system can model what's going on between two scenarios. So again, a linear system, the big thing we want to be learning today, a linear system means we're working with more than two linear equations at the same time. And for review on the first exploratory problem today, we're just given one linear equation, y equals 2x minus 4. They showed the graph for it, and they start talking about solutions again today. So our first key is to understand that a solution, and here's objective number 1, a solution is any ordered pair, any value for x and y, that we can plug into the equation that would make it true. And the key for part 1 today, when they asked us which of the following ordered pairs would be solutions to this green equation that's graphed above, is to understand or remember that every point on the line, every point on this green line is actually a solution, an x and y value that would work in the equation. That's what a graph represents, is every possible solution to the linear equation that we're working with. So the first ordered pair, -4 for x and 0 for y. If I take a look at my graph, -4 for x and 0 for y is right here. That's not on the green line. And if I put -4 in for x, 2 times -4 would be -8. -8 minus 4 would not give us a value of 0 for y. So another reason it's not a solution. But the next value, 0 and -4, if x is 0, y is -4, that's this point right here. Right on the y-axis, right in the middle, so x is 0 and y is -4. That is a solution to our equation y equals 2x minus 4. The first reason that I understand that, first reason I know that's a solution, is really because it's a point on our graph and we already had the equation graphed out. The other thing we can see, if we took 0 and -4 and plugged it into that equation, so if we took 0 and -4 and plug that into our equation, y equals 2x minus 4, we make x into 0 and y into -4. 2 times 0 is just 0, and 0 minus 4 does leave us with -4. We see that that would work in this equation if we plugged in a 0 for x and a -4 for y. The other point, moving a little more quickly, the other point that's on this line that we see here is the value 3 for x and 2 for y. If I look right here, 3 for x and 2 for y, that point is on the line. Since they said identify both correct answers, you would see that 0 and 2 is not on this line. This is 0 and 2. And 2 and -4, x is 2, y is -4. That's not on this line either. So those were also distractors. For part 2, to identify 3 more ordered pairs that would be solutions to this green equation, you're on your own for that, but understand any point on this green line, any ordered pair that falls on this green line is a solution to the green equation. That should help you as you do part 3 as well, which says explain how to find solutions to each linear equation whenever you're given a graph. And again, as we just discussed, the key is which points are on the line of the graph, because all the graph shows us is every possible solution visually represented. That's part A. At this point, now that you understand solutions a little better in linear equations, when part B provides you with a linear system, the purple equation y equals negative 2x plus 6 is graphed out, and the red equation y equals 1/2 x plus 1 is also graphed out. You should have no problem now on part 1 and part 2 to identify solutions to these equations if they provided you with the graph for those linear equations. The key thing, and I want you all to figure this out on your own, so we're not going to review it in the video. The key thing is if we can find solutions, every dot on the red line is a solution to the red equation, every point on the purple line is a solution to the purple equation. If we're given a graph, do we have the ability to find if there are any common solutions? And if you read the objectives today, you know a common solution, simply stated, is a solution that works for all equations in a linear system. And objective 3 can give you a little more detail about a common solution as well. Feel free to let me, Ms. Stewart, know if you have any questions. Make sure that you're filling out part C for the exploratory problems, one new thing you've learned today about linear systems, before you move on to the rest of the practice problems, which are those blue box problems we're showing you right now.